Hey guys, it's time for math today, and we are going to start talking about the metric system. So let's take a look at it. Here's the star chart. We did all of the customary. Don't worry about time. We did all of the customary last week, and the customary system is what we use in the United States of America. But this week, we're going to talk about the metric system because we learned both of them. The metric system is what they use in other parts of the world. So let's talk about the metric system. When I was in your grade level, the customary system was pretty easy for me to understand because that's what we use, like cups and pints and yards, feet. That's something that I was used to. But the metric system was a little bit harder for me to understand how big things actually work. So I made this anchor chart to kind of help us. So when I think of centimeters, I'm kind of comparing it to inches. Centimeters is the smallest when we're talking about length, metric length and metric length only. We have centimeters, and it's one of the smallest units in the metric system. It's about the width of your pinky. Now, I do want to talk about millimeters too. Millimeters is even smaller than centimeters. There are 10 millimeters in every single centimeter. So if I look at the ruler, let's take a look. If I look at the ruler, so this side is inches and this side is centimeters. So this is 1 centimeter. And all those, let me see if I can focus this. All of those lines right there, those are all millimeters. So it goes millimeters, tiny. Then it goes centimeters, a little bit bigger, and that's about the width of your pinky finger. That's about a centimeter. And then we go to meters, and meters is about the height of a kitchen counter. And when I think of meters, I think of like feet and yards. That's about pretty close to it. If you've ever seen a meter stick, it's pretty close. But that's what you can think of: meters, feet, yards. And then we have kilometers. And kilometers is about the length of 6 city blocks. So it's bigger than miles, but it's very close to miles. So again, metric system, when we're talking just about length, we have millimeters, which is, again, super tiny, all these little tiny lines. Then we have centimeters, which is about the width of our pinky. See, about the width of our pinky. And then we have meters, which is about the height of your kitchen counter. And then we have kilometers or kilometers, however you want to pronounce it. And that's about 6 city blocks. So let's take a look at some example problems. What do you think I would measure, or how would I measure? Let's determine the appropriate metric measurement for each of these things. Remember, we start with millimeter, centimeter, meter, kilometer. Okay, so a road between 2 towns. So if I take a look at my anchor chart, my biggest length of 6 city blocks, I would probably measure the road between 2 towns in kilometers, and the only one is A. How would you measure a pencil? Millimeters, meters, centimeters, kilometers. Kilometers is way too big. Meters is way too big. So either centimeters and millimeters. Which one would you do? You're trying to get the closest measurement. I would measure a pencil. This is a marker, but I would measure a pencil in centimeters. That's what these numbers are right here. So that would be 8 centimeters. What about a cone? Have you ever seen a cone maybe on the side of the road or in PE? What would I measure a cone in? Meter, centimeter, meter, centimeter. What do you think? First, let's determine meters or centimeters. Would probably think I would measure a cone in centimeters because meter seems too big. If it's the height of a kitchen counter, my kitchen counter comes up to like a little bit above my waist. So I think that would be too tall for a cone. That would be a gigantic cone. So I'm thinking centimeter, and it's not 1 centimeter because that's 1 centimeter. So it's got to be 400 centimeters. What about a bumblebee? Ooh, a bumblebee is real little. A bumblebee is so tiny, but do you think he's 5 millimeters tiny? That's right here. Do you think a bumblebee is that little? Maybe a fly. Do you think it's 5 centimeters, which is that big? That's a big old bumblebee. 15 kilometers or 15 meters. It just keeps on getting bigger. If I had to guess, I'm going to choose 5 millimeters just because that's a little smaller, and I would hope that a bumblebee wouldn't be 5 centimeters. That would be a big bumblebee. Or even 15 kilometers. Goodness gracious. What about a ketchup bottle? I want you to do the last one, the ketchup bottle and the worm, by yourself. Get what you have in your mind, and then we'll see if you're right. Okay, so for the ketchup bottle, I would probably choose 150 centimeters. And for the worm, I would probably choose 2 millimeters. Oh, 2 millimeters? That's really tiny. 2 centimeters. Yeah, there we go. 2 centimeters. Okay, guys, so let's start practicing some conversions. So everybody get out a sheet of paper, and I want you to draw when we do conversions, what do we do? Input, output table. Oh, yes. Oh, my gosh, you're so smart. Yes, we are going to do an input, output table. So on your paper, I want you to write input, output. And today, we are going to practice what we did last Friday, where they show us these kind of problems, and we have to put it into an input-output table and solve it. Okay, so they're wanting to know 4 centimeters equals how many millimeters? So we need to go up here. And the cool thing about the metric system is it's a lot of the rule of zero. So it should be easier to convert. So first of all, we're looking for centimeters and millimeters. We're going to go find on our star chart which one matches that. So kilometer, meter, no. Meter, centimeter, no. I need centimeter. Centimeter, millimeter. Okay. I need to use this last one. So that number off your star chart is your first number on your input-output table. So I've got 1 centimeter and 10. Oh, I put centimeters. Oops. I meant 10 millimeters. So 1 centimeter is 10 millimeters. They want to know if I have 4 centimeters, how many millimeters am I going to have? So that's how you take this problem right here and put it into an input-output table. You go find the one that matches off the star chart. You put it first, and then you put whatever your problem is. Okay, so let's solve this. So if I'm looking in between these two numbers, I am noticing that I have to find my rule. And when you find your rule, you think either input or output, whichever one, but I'm going to do 1 times blank equals 10. So 1 times what is going to equal 10? I hope y'all are getting the hang of this part easily, and you know that anything times 1 is itself. So our rule is times 10. 1 times 10 equals 10. So now I've got to apply that to my second one. So 4 times 10 equals what? So let's review our rule of zeros. Your rule of zeros is when you're doing, say, for example, 4 times 10. And the reason I'm reviewing this now on an easier problem is because when the numbers get bigger, y'all get confused. So all you have to do is focus on your whole numbers, not your zeros, your whole numbers. So 4 and 1. So first, you're going to multiply those two numbers first. So what's 4 times 1? 4, right? And then you just have to add that 0 back in. So you do the whole numbers first, and then you add that 0 back in. So what's 4 times 10? 40. So on here, I could write 4 centimeters equals 40 millimeters. Okay, let's do this next one. 4 kilometers equals how many meters? So on your paper right now, I want you to write at the top that problem. 4 kilometers equals how many meters? So let's go ahead and draw our input-output table, and then we're going to get it all set up. Okay, input-output table. Okay, so first things first, in order to figure this out, I have to go to my star chart and figure out which one matches it. So I always start at the top, and I try to find kilometers, there it is, and meters, there it is. And it has to be on the same one. So 1 kilometer equals 1,000 meters. So that's going to be our first number in our input-output table. 1 kilometer equals 1,000 meters. Okay, and now I can plug in my problem. 4 kilometers equals how many meters? So guys, what do I do first? What do I have to find in order to get this value? I hope that you said our rule. Miss Simpson, I have to find the rule. So I think to myself, 1 times what equals 1,000? So 1 times what equals 1,000? Remember, anything times 1 is going to be itself. So almost always it's going to be that same number. I'm just going to give you a hint. It's going to be that same number. So if I multiply this times 1,000, guess what I can do to this? Multiply it by 1,000. And you're like, oh my gosh, I cannot do 4 times 1,000. Well, I'm here to tell you, you can. I'm here to tell you, you can. So first we look at our whole numbers and we multiply those first. So what is 4 times 1? 4, right? So then we have 3 zeros right here, and we have to add all of them over here. 1, 2, 3. So 4 kilometers is how many meters? I hope you said 4,000. I hope you're noticing that the metric system is so much easier than the customary system to convert. So let's do one more. And I want you to do this one by yourself, and then we'll check our answers. So we're going to do 600 centimeters equals how many meters? Put that in an input-output table, and I'm going to show you the star chart in just a second. Put that into an input-output table, and I want you to solve it all the way through by yourself. So make sure you pause the video and solve it all by yourself. Okay, so you should have unpaused the video right now, and I hope the first thing that you noticed was there's none that start with centimeters and end in meters. But guess what? It is backwards. It shows you 1 meter equals 100 centimeters. It's the same thing. So we're just gonna put 100 centimeters, which is right here. So meter, centimeter. 100 centimeters, we're writing it backwards, and 1 meter. They equal each other. So now I can take my 600 centimeters and put it right here, and my blank meters. All right, so I like to look at it backwards because I don't want to have to divide. I'd rather multiply. So I'm going to think the output to the input. So 1 times blank equals 100. 1 times blank equals 100. Well, I hope you remember anything times 1 is itself. So this would be times 100 equals 100. So now since we're thinking about it backwards, blank, this blank times 100 equals 600. So what can I multiply times 100 to get 600? Remember our zeros trick. So we have our 2 zeros, right? 1, 2, 1, 2. So what times 1 will give me 6? 6, right? 6 times 100 equals 600. And we could check ourselves by doing this. So 0 times 0 is 0. Or 0 times 6 is 0. 0 times 6 is 0. And 1 times 6 is 6. So were we right? Yes. So 6 meters. Give me a thumbs up if you got the correct answer. All right, so this does take some practice. If you don't understand, please rewatch the video and rework these problems with me, even though you know the answers. Sometimes it's real valuable to do that. So today, guess what? Your paper looks exactly the same as it has been the past few days. You will have to tell me what you would measure each of these items in, and then you're going to have to figure out all of these input outputs. Luckily, most of them already start with your ones. This one does not, so you're going to need a star chart for that, and this one does not either, so you might need a star chart. Remember, if you don't want to divide 40 divided by blank equals 4, do 4 times blank equals 40. Go backwards with it. It's okay. All right, my friends, I love y'all so much. I hope that you have a great and fantastic day. You should be getting the hang of input-output tables and conversions now. So I wouldn't think that any of you would need help except for maybe those 2 on the very last page. All right, guys, I love y'all so much. Have a great day.